Hello everyone. Welcome to the latest in the series of iFormulate Introduces webinar, and today's topic is process control and formulation. So my name is David Calvert and I'm one of the founder members of iFormulate, and I'm joined today by David Hood of the Excellence Partnership, who you can see there on the screen. This webinar, as usual, will last around 30 minutes and it's been recorded, so it will be made available to all the people participating, together with a PDF copy of the slides. If you would like to ask any questions, please use the question box in your panel and we will try to answer them at the end. You've all been muted to prevent background noise, and many thanks to those of you who sent in questions when they registered. We will answer a number of those as we go through today, but those that haven't been answered will be addressed in a personalized email reply. So what are we going to do today? Well, we're going to give you an introduction and talk about the companies and the people you're hearing from, and then we're going to go into what's about process control. We're going to talk about what are the costs of poor process control, give you some tips on the type of tools that are used in process control, and then talk about where to learn more. Now today, those of you who've attended a webinar previously is going to be a little bit different. It's going to be a mix of a presentation and a discussion, and I'm pleased to be joined by David from the Excellent Partnership, who you will hear from shortly. So a little bit about the company iFormulate, those of you who aren't aware of us. We were founded by two experienced industrial professionals, myself and Jim Bullock, and we've been in business now for close on 5 years. We bring our own experiences and knowledge gained across many industries and in varied functional roles, some of which you can see on the slide in front of you. There are times, of course, when we can't cover everything, and we tend to then use our associate partners, and together with their expertise we're normally able to assist our clients effectively, and I'm pleased to say that we work with David Hood on some of those projects. So our services are divided up into three distinct business areas. In iFormulate Consult, we carry out innovation and technology consulting, mainly in the area of formulation science and technologies, and that's for clients and companies in the private sector. At iFormulate Strategic, we have carried out and assisted organisations and bodies such as the Knowledge Transfer Network, the National Formulation Centre here in the UK, and the Royal Society of Chemistry on strategic areas. We help the Royal Society of Chemistry, for example, on looking at the use of big data in formulation. Under iFormulate Skills, we design, deliver and promote training courses and programs in formulation science and technology, which may appear under our own banner or may be in partnership with third parties. A good example of one of those was this year we helped to organise for the third year a spray drying course with the University of Leeds. But this webinar is part of the iFormulate Skills activity and forms a series of webinars. At the end of today you'll see details of a number of those, but if we don't have time to go through them, you can see them on our website, and if you need passwords then please get in touch with us at info@iformulate.biz. So having talked about iFormulate, I think it would be remiss of me not to talk about the Excellence Partnership, and they're a firm of improvement specialists who help businesses to significantly and sustainably improve performance and obviously then profitability. They're highly experienced professionals, similar to iFormulate, who are experts in developing excellence throughout their organisations. They tend to challenge clients and they want to change the way that they work and maximise their true performance potential. So I'm delighted, as I said, to be joined by David Hood. So welcome to you, David.
Thank you. Hi, good afternoon. And yeah, good to be here.
Okay, so we've got a title of process control and formulation. So I guess we should start with the obvious question of what is process control? So David, what is
Right, okay, process control. Very broadly, a very broad process used by many organisations. And perhaps the best way of describing it is you can see on the slide, it is probably the main approach organisations take to understand and manage and ultimately control the variability of processes. If we recognise that all processes that we have, whether it's a process in production or even a process in R&D or a formulation process, we will always get some form of variability in the process. And applying process control, the methodology of process control to processes, allows us to minimize that variation excuse me, minimize that variation, and in minimizing that variation, we're then able to reduce the amount of waste that we see through the process. That's perhaps the best way of describing it.
So you use the word production there, David. So, I mean, is it just production who's responsible and manufacturing is responsible for this?
Well, process control, or in many cases, it is production or manufacturing who tend to pick up process control. Once something has been developed and transferred into the production environment or the manufacturing environment, it is often those people who then apply the methodology of process control. But actually, it isn't just manufacturing who need to be aware of this. It needs to be everybody in the business. So I guess that's why the whole topic of process control under R&D and formulation in the webinar here is that it shouldn't just be manufacturing. It should be the whole business who understands process control and uses it to, as I said earlier, manage and control the variability of processes with the view of minimizing waste, minimizing variation and waste.
Okay, that's a good introduction. I mean, I guess we've got the title of process control and formulation, so I really wanted to just talk initially about, let's talk about what formulators are trying to achieve in production. You're trying to achieve output. What about formulators? Well, on this slide you'll see some of the things I guess that people are trying to do in formulators. They're trying to make informed decisions and maybe probably the glory of doing new products. But it is all formulators now are up against a background of time and resource pressures, and they need to improve their productivity. So it's not just production that's got to improve their productivity, but formulators. David, is that the way you see it as well?
It is, and I think what you tend to see in so many organizations, and I've seen this in lots and lots of different businesses, that the production activity or the production environment and the manufacturing environment suffer the consequences of not having controlled processes developed prior to transfer into manufacturing. I think the thing that I see, and this is not a swipe at people in R&D or the formulation process, but their goal quite often is, look, if we can create this new product, if we can create this new formulation or this new service and get it on the market early, we win competitive advantage, and that's great. That's fantastic. It allows an organisation to steal a march on its competitors. But if we don't consider how beyond transfer to manufacturing, how we're able to maintain and manage, how we're able to control our processes or our process variability, then we are setting ourselves up for a bit of a fall. So, I think too often the R&D aspect is launch it at this date, get it launched quickly into the market, and don't focus enough on making sure that when it is launched, the factory and the manufacturing operation can continuously produce this with the levels of profitability that the business requires.
Yeah, and I guess that's down to sometimes division of responsibilities and people thinking their job ends at a certain stage. But
it does.
I guess one of the key things that can drive your activity is to try and understand what happens when you get something wrong. So it's worth looking at what are the costs of poor process control. And on the next slide, David, I think you put together a few of your ideas there, and perhaps you can talk through them, but pick out maybe two or three that you think are the most important in terms of these costs.
Okay, that's good. That's a good point. I mean, I think we've captured quite a number there, but the one that is so obvious, the one I see is the top one on the left, and the obvious point around excess raw materials. If we don't have a tightly controlled manufacturing process, then we get huge amounts of variability, and as a result of that, we tend to be, most organisations err on the safe side. And consume or buy in more materials than they actually need, which costs the business a huge amount. I think I remember coming across quite a number of years ago, very typical costs in a manufacturing business. 60% of costs are raw material costs. Now, some of the people listening in, their costs might be slightly different, but quite often raw materials cost about 60% of the overall cost. So if we are using more materials than we should be, then that's going to have a significant dent on profitability. I think the other one, suggesting picking out two, is around the hidden costs, the loss of management time, the loss of production time in actually looking and trying to understand why we're losing profit in a manufacturing process, in an uncontrolled manufacturing process. I kind of put that under the hidden title there. Troubleshooting costs, lost production capacity, reputation, all of those hidden costs that businesses just don't see, that get lumped into an overhead, and those can be huge as well. That's what I would see.
Yeah, I mean, I think I'd agree with some of those. I mean, often I've done work on companies where they've been looking to reduce their waste, and they regard their costs just as the waste disposal costs, and they actually forget that there's some raw materials in that waste that could have been turned into profit and could have been turned into some margin. So I think that's often missed a great deal. And I agree with you. We're often, R&D, I've a number of times dragged onto a factory to try and sort something out, and in hindsight, that wasn't just manufacturing getting it wrong, it was me not developing the product correctly. So I think all of those things tend to lead to reduced profitability, as you say. So if we're in that area, what are the type of tools you can use in process control, Dave, to try and drive us to that better end?
Okay, well there's a lot of ideas and principles and concepts and basic tools and techniques that we could use, and we've just captured a few of them here, and because I think these are probably the critical ones. All businesses that are involved in formulating a product to bring something new to market need to have a very clear, what we've titled there, new product development process. This isn't a slide on acronyms, so I apologize for those, but they need to have a NPD, new product development, or NPI, new product introduction process, and they need to have a very structured way of creating new products and introducing them into the manufacturing facility with clear steps and milestones in the process. That for me will be the first point. Second point would be around real clarity on what it is that the customer wants. People sometimes refer to this as the voice of the customer. I sometimes, okay, that's absolutely fine, we just want clarity on what we want, but the voice of the customer, absolute clarity on what it is that the customer wants. And we need to have that in very specific terms. So quite often customers don't fully appreciate that, but if we can understand what it is they appreciate, we can then use the third tool, termed quality function deployment, or QFD, to translate what it is customers want into very tight specifics or specifications for our manufacturing operations. So start with a new product development process, obtain voice of the customer, QFD gives us the specifics. I then perhaps go into design of experiments as a methodology for proving the best formulation, but I think you were going to talk about that a little later on, Dave.
Yeah, I am. Yeah.
And then the last 2 points is about having good measures and understanding what they mean to know whether we have a tightly controlled process, and that's the process capability measures, CP and CPK, and then control charts, which are a graphical representation, or a graph is a better term perhaps, to show how our process is in control or it isn't. And too often, organizations certainly don't have those latter two elements, and therefore don't know whether the process is within control or not. If we could perhaps just move to the next slide, Dave, if that's okay.
Yeah, just before we do that, I mean, I'd just back up something you said about the voice of the customer there, and I've often called it the customer promise, and it's difficult, but it needs to be quantified as well. So quite often you'll get a brief that it needs to be better in terms of a specific property, but there's no definition of what that is, and that makes it really difficult, I think.
I think you're absolutely right, and I've seen so many organizations, when it comes down to it, not fully appreciating what it is that the customer wants, which gives them huge problems down the line.
Yeah. Sorry, I interrupted your flow there. We said, what tools can you use in process control? So you're about to tell us a little bit about some abbreviations and formulas there.
Yep, yeah. So perhaps couldn't leave a webinar without a few formula. Hope people stay listening. Process capability, say CP and CPK, and these are formula which allow us to understand whether our process is in control. So we can see the top formula CP is simply a measure of the upper specification limit minus the lower specification limit. So that's the specification that we need to sit between, divided by 6 standard deviations. And a standard deviation is the spread of how spread the variability of the process is. So if you think of a great way, somebody once taught me to consider this, if I am driving my car into my garage and the car exactly fits in my garage, then my USL minus my LSL, lower specification limit, divided by my 6 standard deviations would equal 1. That means my car just fits in the garage. If my car fits in and can move half a car to the right or half a car to the left, then that would be a CP of 2, and that's a way of thinking about it. If you're sitting at a CP or CPK value of 1, you're just on the limit of sitting within your upper and lower specification limits. If you have 2, then you have quite a bit of a margin either side. I would say quite a number of years ago, people often talked about CP or CPK of 1.33 as being what really customers want, but I would suggest it's more now closer to 1.67 is really what we should be aiming for.
Okay, so I guess it's pretty standard practice this in any manufacturing outfit, CP and CPK. Do they report that regularly, part of their KPI?
Do you know, I don't see enough organizations reporting that. I do see some, and some are very good at it. I think because it's a little bit based on statistics, people can shy away from it. It really is quite a simple concept. You know, I've worked with some organizations who absolutely get it, and everybody talks about CP and CPK, and they completely understand what that means, and that's fantastic. If you can get your organization to understand the figure and how it is calculated, then that's really good for the organization. I've seen some organizations really not understand it and not appreciate it, and they're the ones that obviously need it most.
I guess there are software packages though that can remove that fear of stats, are there, that are fairly simple to use? There
are many software packages that can help you work out CP and CPK level, or CPK figure, sorry. Do you know what, I would go for a very simple Excel spreadsheet. You know, it's really quite simple to set it up. You don't need lots of, you know, most probably all organizations have Excel, Microsoft, or some form of spreadsheet. You know, it's very simple to set up a calculation for this, and you know, software packages aren't necessarily required. Quite simple to set up. But yes, of course, there are software packages that can do this.
Yeah. Okay, so we're going to move on now. Thanks for that, David. We're going to move on to some questions that people submitted on their registration. So I've put a few up here, and let's just take that one up on the right-hand side first. What would make the flow from innovation team to the factory easier? And that was submitted by Ruth Dolby of Food Science Fusion. So, David, what would you say first of all?
I'd pick out 2 things from this. It's very interesting, your comment a few minutes ago about when you said you felt the objective, or sorry, in the past you had, or sometimes felt the objective was to get things out in the R&D to meet a certain date and then pass it over to manufacturing. The thing I would say that too often we're not working as an entire team on this. You know, R&D and manufacturing are not working collectively. Good organizations that get this right have great teamwork, and that is right up and down the process. So any new formulation or any new product or service that comes in is easily transferred into manufacturing. So I would put teamwork, you know, right at the top. I think the second element I would say would be about having a very clear NPD, new product development, or NPI, new product introduction process, one that everybody adheres to, that's got very clear milestones in it that we cannot continue down the process until we've carried out all of these activities. So two things I would pick up from there are MPD process and teamwork.
Yeah, I think I'd echo that, and we'll come a little bit later to how if you have a process in place where that actually is, and the clarity of the brief comes up over and over again. So voice of the customer or customer promise. So we'll come to that a little bit later. Now, Enrico Zambelli, how can you define the process variability? I guess you covered that a little bit, but I'm just interested in, do you do CP and CPK on just what comes out at the end, or is there some benefit to doing it earlier on?
Well, there's a huge benefit to doing it earlier on. Most organizations would start at the end because, you know, that's where we're seeing the variability. That's where we're seeing this huge discrepancy against the upper and lower specification limits all too often. So most organizations would start that. But the best place to do it is right at the very beginning, if we can, before we start the process. Because in reality, if the product has got to the end and it is outside the upper and lower specification limits, or if the process capability is under 1, that means product is falling outside those limits, then it is already waste. And there's really nothing we can do unless the organization has the opportunity to rework it. There's really nothing we can do. However, if at the beginning we're monitoring the variability, and we see it start to deviate or drift, then we can do something about it before we get the waste. So, you know, you're absolutely right, Dave. It's far better doing it earlier in the process if we can.
It's getting control strategies in place, isn't it? So remedial actions before it's too late. Yeah. Okay. So Federico from Agrofenia has asked, quite obviously, what about an example of process control you've seen in formulation R&D, David?
Well, I've seen an organisation that was a FMCG, fast-moving consumer goods business, where product was launched into the facility, and because there wasn't a real understanding in the R&D aspect of process control, what was happening was that bottles were being filled with product, and they were giving more product away to the customer than they needed to. And of course that's great for the customer, but it was hugely damaging in terms of profit for the business, because they didn't have that complete understanding of process variability as it got transferred into the factory. So the factory were dealing with a very variable process, which was they were spending huge amounts of money on because of the cost of raw materials.
Yeah, so that's waste and raw materials. So I think that's a good example. So if we move on now, Paul Wilson's asked us a question here, and I think I'll field this one to start with, which is how can you understand or determine what interactions are present between components of a formulation during blending? And I guess I'd like to deal with this in two parts. It says understand and determine. Well, determination of those interactions, which take place during lots of formulation process, is one of the most difficult things to do, and a one-by-one, the traditional intuitive design approach doesn't normally get you there. You can be lucky, but it doesn't normally get you there. And this is where I think experimental design plays a key part. And you've got here a slide which just shows the types of designs you can do and the types of responses you'll get, but very powerful, and certainly something that you should be looking at if you're dealing with any sort of interactions. But if we're talking about determining them, and then the next part of the question from Paul was about understanding those interactions, and here you've got to go back to the human brain really and start to look at some of the science that's involved. So what is the science that underpins what you're doing in the formulation? Is it colloidal science? Is it crystallization? Do you need to understand a little bit about zeta potential? Maybe you might not think in a liquid blends, but you might be doing a suspension. If you've got a whole bunch of surfactants in your blend or in your product, then there's competitive absorption onto solids, or they can actually interact with one another, and you need to understand what's going on there. And quite often you have rheology. So rheology can be influenced by many things, and it can be an effect of the salt, the pH, or the surfactant, or indeed a combination of them all. So trying to understand, and I'm aware sometimes people think of black boxes in experimental design. They're not a black box. They'll give you a model and a move of direction, but it's really down to the formulator to understand what's going on. Next question comes from Dave Willoughby from Sanofi. He says, what process parameters are critical to consider for scale-up of a coated tablet? Well, that's a rather specific question, but I guess it's interesting that really for everything that you're doing, you need to follow a flow. And I said we'd cover this to a certain degree, and this is the flow we regard for product development. And you get started, you start to understand what's going on, you go into the lab, and at each stage of these processes, you move to the pilot scale and then into manufacture. You're looking at learning more, and you're looking at doing a risk assessment of what is actually happening throughout your whole process. So if you're doing a tablet coating, you'll have done some lab work, you'll have done some pilot scale work, and that should help you actually with your own knowledge to understand what are the critical parameters, which may be part of the spec, but maybe something else that's in there. So I hope that's answered a little bit. We're not going to have time to answer too many more, but David, as we're coming to the end of this, you put together this summary, so perhaps you can summarize now.
Okay, I think some key things that we need to really understand about this is we do need to understand, and we do need to be able to measure customer requirements. Voice the customer promise, we need to understand it, and we need to understand it in clear specifics. We need to be understanding and measuring our processes so that we can see the amount of variability that we get in our processes, and the key tools we want to be using are, CP, process capability measures, CP and CPK, and control charts to help us see the drift of our processes. We ought to have a very structured and apply a very structured and rigorous NPD, NPI process. And the thing I would suggest really is we really need to be focusing on the long term. This is not just about getting to meet a particular date so that it can go on the market. It's recognizing that we do this so that we can be producing this for many years and producing it at a profit.
Okay. Well, thanks for that, David. And we've tried in 30 minutes to give people an overview, but obviously you can only do so much in 30 minutes. So we are actually doing this. This is covered in 2 days, and even then we have to skim over some aspects. But we've got a 2-day training workshop which takes you through that whole process I've outlined on design for formulation, the product and the processes. That's on the 19th to the 20th of September near East Midlands Airport in the UK. There's a price there before August the 1st, and you can get more details if you follow that link when you get this slide through to our website. I did touch a little bit on some other webinars that are available, and on this slide you can see a list of those that are available. We talk about Hansen solubility parameters, adhesion science, with Professor Stephen Abbott, the mysteries of powders with one of our other associates, Ian Jolliffe. You can see inkjet, spray drying, crystallization science, open innovation, and Malcolm McKechnie talks you through that in half an hour, suspensions, and something where we did a while ago where Ian Jolliffe taught people through about what you do before you even go into the lab, which has a bearing on lots of the things that we've talked about today. So you can see a full list there, and if you will need a password to view those, and you can get those by emailing info@iformulate.biz. So we are coming, we always stick to about our 30 minutes, so we are coming to the end. Apologies to those of you who sent in questions towards the end. We will get back to you with answers to those questions personally on an email. You will be sent, as I said at the beginning, you'll be sent a recording of this webinar and the PDF slides. That follows automatically in 24 hours, and if you want to see more of what we're doing, you can follow through onto training and our events. So all that remains to me is really to say thank you to David, and thank David for his time and input today. David, you're
very welcome. It's been good talking to you.
Okay, so we hope that people have enjoyed this rather than just presenting a little bit more of a discussion. We'd like to thank you for your attention, and we hope to see you again at another iFormulate Introducers webinar in the near future. So thank you very much, and have a lovely day. Take care. Bye-bye.
Bye.